Hi everyone, we are back. We are working on day 2 notes from Unit 8 about volume and area and conversions. So we did all this already in day 1 video. So now day 2 or part 2 of this, we are going to go to this page and look at the area formulas. So on your reference sheet, there are 3 area formulas. They are the ones that start with A. So you have triangle, parallelogram, and circle. But there's many other shapes other than these 3. So if I take the area formula for a parallelogram, A equals BH. So I have parallelogram. Here's what a parallelogram looks like. Here's the formula that's on the reference sheet. Now you need to know what these things stand for. Lowercase b stands for the base, capital or lowercase h stands for the height. So in a parallelogram, your base and height are always perpendicular. So you're looking for that right angle. So very important for you to know, base and height are perpendicular. So you look for the box. And then all you do is multiply those together. A stands for area. Now a rectangle, here's a picture of a rectangle. The formula for a rectangle is actually length times width. But this same formula works, base times height. Because in a rectangle, here's your length, or you can call it the base. Here's your width, you can call that the height. So the same formula works. Also in a square, instead of memorizing the area of a square side times side, it's the same formula, it's base times height. It's these 2 measurements multiplied together. In a square, all 4 sides are the same length, so you're multiplying the same number together. So then, so all 3 of those shapes use that same formula that's on your reference sheet. Triangle, that formula is on your reference sheet. It's A equals 1/2 base times height. So here is a right triangle. Again, you're looking for the box for your base and height. Here's a picture of a different triangle. Sometimes the height is drawn inside. And sometimes if you have an obtuse triangle, you have an angle greater than 90, the height is going to be drawn on the outside. Here's your height, here's your base. So there's little dotted lines sometimes to represent that length, that measurement. So 1/2 base times height. Now it's the exact same formula as that, but it's half. And here's why. If you were to connect a diagonal of a parallelogram, you end up with 2 triangles inside. So we don't want the area of the whole thing. We only want half of it. We don't want the area of both triangles. We just want one. So it's half the area here. Same with a rectangle. If you drew in the diagonal, there's 2 triangles in there. Same with a square. But we only want the area of one triangle, so it's 1/2 base times height. All right, a circle is the formula pi r squared. R is your radius. Now sometimes the diameter is drawn. Diameter goes all the way across the circle through the center. So you need to know the relationship between diameter and radius. A radius is your diameter divided by 2, or a diameter is 2 times your radius. So you have to just kind of be aware if they give you the diameter, you have to divide it by 2 to get the radius to put that in your formula. And we are going to be using the pi button on our graphing calculators, which is right here. Second caret button is your pi. So if you ever wanted that value, if you hit second pi, pi will show up on your screen. If you were to hit enter, there's your value of pi going out many decimal places. So we're not going to use 3.14. We're going to use the pi value on our calculator. And again, we're going to leave it out to 4 decimal places until the end of the problem when it'll tell us what to round to. Now another formula on your reference sheet is circumference of a circle. And there are 2 of them. So C stands for circumference. It's pi times d. But now remember, 2 radii is the same as a diameter. So here's your 2 radii. So these 2 formulas are the same. One is given to you in terms of the radius, and one is given to you in terms of the diameter. But you need to realize circumference of a circle, it's kind of like the perimeter. P-E-R, I'm spelling it wrong. P-E-R-I-M-E-T-E-R. It's the same as the perimeter. It's your distance around the outside. So those are all on your reference sheet right here. Area, 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 and then circumference of a circle. All right, next you have all these formulas for volume. So here's our 5 three-dimensional shapes we were talking about. Here's all the area, or I'm sorry, the volume formulas. So I have them all on the next page. But again, it's important that you know what the variables stand for in the problem. So V is volume. This is for any prism. And it's capital B times H. Now, nowhere on the reference sheet does it explain what capital B stands for. You need to know that capital B is the area of the base shape. The area, very important. Volume is determined by something called the stacking principle. And the stacking principle would be like if you, for example, found the area of this circle, and then we have a cylinder here. It's how many of these you could stack inside. It's how many would stack all the way inside. So you find the area of 1, and if you multiplied it by the height, it would tell you how many of these would stack up inside. That's called the stacking principle. So the height is how many of them would fit inside. So it's really just the area of the base shape times the height. So that's why it was very important for us in day 1 notes that we were able to identify what the base shape is. Like the base shape here is a triangle. So you are going to use your area formula for a triangle and then multiply it by the height of the whole shape. The base shape in this prism is a rectangle. You find the area of the rectangle, multiply by the height. All right, a cylinder. The volume formula is actually the same. They're all the same. They're all really area of the base times the height. But in the cylinder, we know that the base shape is a circle. So on the reference sheet, they filled in the area formula for a circle for us because the cylinder always has a base of a circle. So you find the area of one circle multiplied by the height. The volume of a sphere is kind of a weird one. It's 4/3 pi r cubed. This is the only formula that has a cubed in it. So people tend to just do squared. So it's the radius times itself times pi times 4 divided by 3. All right, but this is the only formula that only has one variable. You only need the radius. All right, a cone is 1/3 pi r squared h. Now, pi r squared h is the same as the volume of a cylinder. So technically, you're taking the volume of a cylinder and then 1/3 of it. So here's our cone. Here's our cone. Here's our cylinder. And the reason it's 1/3 is if I put this cone inside, it fills up 1/3 of it. Like if I filled this cone with rice and poured it into the cylinder, it would take me 3 times to fill this up, to get it to fill up the cylinder. So it's 1/3 pi r squared h. All right, pyramid. 1/3 capital B times h. And again, capital B is the area of the base shape because a pyramid can have a triangular base shape, it could have a square base shape, it could have a pentagon base shape. So it's the area of the base shape times the height. And again, you know, you kind of look for those little perpendicular markings in there to find your height. But then it's 1/3. Why is it 1/3? So again, like here's a cube. Here's a pyramid. If I put it inside, it only filled it up 1/3 of the way. So again, if I were to fill this up with rice, it would take me 3 times to fill up the yellow pyramid and dump it into the cube. It would take 3 times, which I'll demonstrate in class. So there's your formulas. They're all given to you, so you just need to know how to use them. All right, let's flip and try some examples. All right, number 1, find the volume. Now remember, step 1 is you always need to check your units. They all must be the same. You may have to convert. All right, we have 0.12 m, 4 cm, 3 cm. We have centimeters and meters. They are not the same. So we first need to convert. This is the metric unit. So that scale went King Henry died while, that's our units of measure, that's meters, drinking chocolate milk. So if I want, these are already in centimeters, which is right here, and this one's in meters. I'm starting here. I have to go 2 places to the right. So I'm going to move this decimal 2 places to the right. So this turns out to be 12 centimeters. So now they're all in centimeters. You could have also changed these to meters. Our final answer is going to be different depending on if it's in meters or centimeters. So I decided to go centimeters because these were already in centimeters. All right. Second step is you have to identify your shape. This is a prism. So that's like step 2. Identify your shape. This is a prism. All right, so you need to choose the correct formula. I'm going to add that in. Choose correct formula. This is a prism. Oh, actually, let me do dot dot. So volume equals big B times H. You can get that right off your reference sheet. Big B stands for the area of your base shape. This is a rectangle. So I'm going to do my length times my width, and the height of the whole shape is 12. So it's just 3 times 4 times 12, which is 12 times 12, which is 144. If you don't believe me, you could type it in. So 144. Now we are not done. You must put the units. Centimeters times centimeters times centimeters is centimeters cubed. Like I said, if you did all this in meters, it would be a different answer. So it is very important you have the correct units. All right, let's check out number 2. Find the volume to the nearest tenth. All right, at the end, we're going to have to round. First of all, I'm going to check my units. Centimeters, centimeters, centimeters. All right, I don't have to do conversions. Next, I need to identify my shape. This is a pyramid. It comes to a point. So the volume of a pyramid is 1/3 big B times H. Big B is the area of the base. Okay, the area of the base is just a square. So I'm going to start to substitute in. So I'm going to do 6 times 6. Now I need to multiply by the height. They did not give me the height. There's also an X here. All right, there is something called a slant height. The slant height, if I have my pyramid right here, is actually this measurement. See this triangle on the side? It is the height of this triangle that's on the side. That is completely different from the height inside the shape. See, I'm putting my pen inside, kind of where this is. That is the height of this pyramid. They gave us this. So can you start to see, this is wiggling, hang on, I have to get coordinated. Can you start to see what's going on here? There's the height inside, here's the slant height. If I connect down here, it makes a right triangle. So it's a little bit easier to see right here. We have a right triangle. That means I could do Pythagorean theorem because I know this is the hypotenuse of my right triangle. It's slanted. Here's what I'm talking about. Let me put it in red so you can see this right triangle better. See that popping out now? All right, so we only have one side to this right triangle. But if this is 6, any guess how long that is? I hope you said 3. It's always going to be half, because this triangle kind of goes halfway through, halfway that way. So that's 3. So my only missing variable is H. So I'm going to do that math over here. So this is a right triangle. So one of my legs is 3, the other leg is H, and this 5 is my hypotenuse. So I have 9 plus H squared equals 25. Subtract the 9, H squared equals 16. Take the square root. My height is 4, and it's all still going to be in centimeters. All right, so now I'm going to substitute in that 4. So here's how you just type this in. We go 6 times 6 times 4. You could hit enter. You're going to divide that whole thing by 3. All right, so it's 48 Now, if you didn't like that, you could type it in exactly